So in this video, I'm going to narrate about shortest job first algorithm. Actually, what this algorithm will do is like it will arrange all the process based upon their burst time in an ascending order. Say ascending order mean like if the process burst time is 1, it will be taking the first one. I mean the process will be executed first when compared to the process which has a burst time greater than 1. So say here I'm taking like all the process will be arriving at the same time. We are not going to consider the different arrival time scenario here. So all the process will be arriving at the same time, and our algorithm is going to arrange the process in such a way that the process which has the lowest burst time will be executed first. So to continue execution of this thing, I have created a structure as we have done in other program. So the structure is like I have named the structure as process, and we have a process ID and burst time, and I have a number of process like P of 10. I am saying that we can get the process 10 different process, and I have declared I and n in the main function. When you if you have watched the previous video, I have mentioned like I is used for loop and n is for getting the number of process. And I'm going to use the for loop to get the value for process ID and burst time. And so as of now, it is okay like to get the process ID and burst time. And I told already that dealing this type of algorithm using structure will be very easy, because we need not if we go for like array structure, if you are going to implement in the form of an array, there will be confusion like how to allocate that corresponding burst time for a process in that way. Here there will not be an issue while you are using a structure, because structure itself will be having and single object will hold the values for process ID and burst times. So it will be easy for us to make a swap or assign the burst time to a particular process. It will be very easy for us if we are handling this type of thing using structure. So first of all, I'm getting input like, say I'm going to get the process ID and the burst time. So next I'm going to do like ready queue. I'm going to print the process which are in the ready queue. Ready queue is like it will be the queue where the process will be executed. The process will be taken from the ready queue and it will be executed one by one. So the ready queue is where the process will be waiting for execution. That is the thing. Again, burst time is nothing but like how much minute or time the process will be process will run. That is a burst time. And process ID is like for each process we are giving an ID. So here I'm printing the ready queue. For that I'm printing the process first, and then I'm leaving a tab space and I'm printing the burst time, and then I'm going to put the for loop, and in the for loop I'm going to print the process ID along with the burst time. So this percentage d, I'm going to give some space to the percentage d so that the print statement will like leave some space. Process ID comma p of I dot burst. I'm going to leave a line space. Can run and check. Okay, there is some error. Okay, there's extra burst is there. I can delete that. You can run now and check. I'm entering the number of processes 3. Okay, I've entered 1, 2, 3 the process ID, and when given a number as 23, 4, 4, 2. This 23, 4 and 2 are the burst time. So the maximum amount is coming at the top. So we need to do an algorithm like our algorithm, as we told, like sorter's job is going to make the ready queue as like the first process that we are going to take from the ready queue will be having lesser amount of burst time. That is the thing that you have to arrange. So for that purpose, I'm going to declare some keyword like swap. SW I mentioned as swap, because I'm going to do a swapping here, and I'm going to use another variable for j. Like I'm going to go for 2 for loop, so I'm introducing j variable. Now what I'm going to do is I'm going to swap the process in such a way that the swapping take place. Like I'm going to bring a process which is having a lesser amount of burst time in the front of the queue, so that our execution starts by the process which is having less amount of burst time. Like this will take care of that swapping. I'm going to compare the burst time of the first process with the burst time of the next process. So in our case, the 0th process and the first process. So for comparing, I have introduced the variable j. So and inside this I'm going to do a swap function. I have created a variable SW for that structure, so it is easy for me. I am going to assign the value of p of I into swap, and p of I is equal to p of j, and p of j is equal to SW. It's a normal swap function where I am going to swap the greatest process with the burst time. I mean greatest burst time with the lowest burst time. I'm going to swap the process based upon their burst time, and I'm going to print this thing. The above statement will print the process and burst time. So I'm going to copy and paste it. This is like after swapping. Before swapping we will be having that the input, and after swapping we'll have the ready queue as the ready queue based upon our algorithm. We'll check. I'm going to give an input. So now you can see the process 3 is taken first because it is having a lesser amount of burst time. Then comes the process 1. There is some issue. I'm going to fix that now. Okay, we'll check. Okay, so the variable for j we have to give I. So I'm comparing it with 1. So we have to change it into I. J must be equal to I. Okay. So now we can check it again. So now you can see clearly that the second process which is having a less amount of burst time executed first, then the third process is having 7, and then the last process is 1 because it is having the burst time of 24. Now it is the processor correctly swapped. That is like the process which is having less amount of burst time is brought to the top. Now we can print the Gantt chart. You know what is a Gantt chart? Gantt chart is like we'll have the process in middle, and in the left we'll be having the starting time of that process, and in the right we'll be having the starting time plus burst time of that process. That is the thing that will be printed in the Gantt chart. So for this I'm going to print the process ID first. So I'm introducing the for loop. Within the for loop I'm going to print the process ID. I'm going to leave the process ID, which is like %d comma p of I dot process ID. Okay, I'm going to leave some tab spaces so that there will be some space after printing the process ID. So print of /t and /t, I can give extra t2 here. We'll check, and I'm going to remove a line space. These are all for alignment purpose. and I'm going to print the starting value. So for that I'm going to declare a variable which is temp. I'm going to use the for loop to print the temp values. This thing, like we followed in each and every algorithm, you can check with the first starting algorithm, which is CFS, that we have done a video for that too. So initially we'll print the temp value, which will be 0, which will be in the starting time of the process, and then we'll add the value of the corresponding process with the temp value, and we'll print it again, which will give us the burst time, like how much time the process is spending from the starting time. That will be given by the value of temp is equal to temp plus burst time. So I'm just printing those values, and I'm going to we'll run and check what is the output in that way. Just random values. Okay, we are getting some wrong outputs here because the Gantt chart, the arrangement is okay, fine, the process is executing in the correct way, but we are getting some values which is 63,000 in that way. So there is some mistake with this, like I didn't assign a value for temp. I already told that the temp will have some default value. So that we should initialize a value to 0, the temp value to 0. So because each time it will have some old values which is stored in temp, that we should eliminate. You can check the output now. The third process is taken from 0 to 2, which is correct. Then the second process from 2 to 5, that is 7, that is 2 plus 5. Then the third process is from 7 to 31, that is 7 plus 24. It is running fine. So the values comes correctly. Now we can calculate the waiting time of this process. So that I'm introducing a variable which is like waiting. So the waiting time means like how many minutes a process is waiting for its execution. That is a waiting time, which will be obtained by the starting time of a process. That is a thing that we can assign. And initially, like first process will not wait for any amount of time. So that I'm going to assign that is p of 0 dot waiting is equal to 0, which means that that the process which is comes first will not have waiting time, because the first process will not wait for any other process. It will be simply executing. So that I'm making that p of 0 dot waiting is equal to 0. That can be any process, because we are shuffling after that, after getting the input. So I'm simply assigning p of 0 dot waiting is equal to 0. Here I am assigned a condition like if I not equal to 0, because when a process is not equal to 0, I'm going to change the value of the waiting time. So the waiting time, initially it has to be the left hand side value of a process. In the Gantt chart, it has to carry the left hand side value. So that I am assigning the p of I dot waiting is equal to temp in that position, like in the 58th position, because initially I am printing the temp value in the 56th position, where it has been the left hand side value of the process. So in the 58th line, where I am assigning p of I dot waiting is equal to temp, which means that it is going to hold the starting time of the process. Starting time means like the process is waiting for its execution until that time. Only the process starts from that starting time. So it is waiting before that. So that is the exact waiting time of that process. I am just printing process ID along with your waiting time. Just we are giving initial values. So the alignment is not so correct, like I need to bring this down. So we can introduce a slash in here. Okay, I think it will give some error, so I'm putting it down. I can remove this and I can print ln in the new line. And similarly here one print ln to bring all those things down. Okay, now we can run and check. Okay, our waiting time is little different. Like waiting 3, I've printed the burst time instead of the waiting time. Like I need to assign the waiting. See, I have printed b of I dot burst, which is wrong. Like I need to bring the waiting time here, process ID and p of I dot waiting. I need to change the burst into waiting because we are seeing that waiting time. Now we can run and check. Okay, it is correct now. The third process starts from 3, second process starts from 2, and the last process, that is 1, starts from the 5. It is correct now. Now we can calculate the average waiting time. For that, I'm going to introduce a variable like int average waiting time and some other variable tw. So I'm going to assign this tw to 0. You know what will happen if you didn't assign that value as 0? It will hold the previous sum values and it will give us a false sum. I'm going to sum all the waiting time, and at the final stage I'm going to do an average of that. So average of w is equal to tw slash n. N is the number of process, so I'm going to n. Then I'm going to print the average waiting time here. I'm going to give that keyword avgw. So this will print the average waiting time, which will be working fine, I think. Just mistake here. So avn I will remove it. It's okay. Now we can calculate the turnaround time. So turnaround time means like nothing but how much time the process is in the ready queue, like how much time it is been in the ready queue, and when it's complete the execution. It is the amount of time taken by a process to complete execution. That is the turnaround time. So I'm going to create a variable for calculating the average waiting time and average turnaround time. So what is that is like turnaround time will be in the right hand side of the process. That is why I assigned the thing in the 62 line, the line 62. In the 61 you can see that the right hand side value for the Gantt chart has been calculated there, which is like temp is equal to temp plus p of I dot burst. So it is mean that from the starting time how much time the process is taking, that will be taken care in the line of 61. So in the line 62 I am assigning the tan variable to the temp value, which will give us the right hand side value of a process in Gantt chart. So that is the turnaround time. So I already told you the turnaround time is nothing but the amount of time a process takes for completion. So that is the turnaround time. I'm going to copy this and I'm going to paste it here. So everything as normal that we have done for waiting time, that will be the same. So instead of the waiting time, I'm going to put turnaround time, tan. I'm going to replace it with the turnaround time. And instead of waiting, I'm going to put tan. You can run and check some random values. So 2 3 5, okay, 2 3 1, like the first process is 3, that is okay. So everything works correct. The first process that is going to be executed is 2, which is from 0 to 3, and the next process is 3 to 8, because we have burst time of 5, then 1 8 to 28, that is correct. So waiting time first process is 0, turnaround time is first process is 3, that is correct. Then waiting time for the second process 3 is 3, which is correct, and the turnaround time is 8, correct. Then last process turnaround time is 28, it is fine. So now we can do the average waiting time, which is 3 plus 8, which is like 11 divided by 3, which is like 3 only. And because we are doing in the integer calculation, then the turnaround time is 3 plus 8 plus 28 divided by 3, which will be 13. That will be a correct answer. You can check it. Thank you.